Greetings to all of you. In today's session, we are going to start with the intermediate chemistry. This is very much helpful for the international entrance examinations. If you are preparing for any competitive examinations on the international floor, this kind of session will be very much helpful. In India level, JEE Advanced and JEE Mains examination for NITs and IITs Technical Engineering stream, and also for NEET chemistry for the medical entrance examinations and all over India level. So Telangana MSET and Andhra Pradesh MSET examination for the entrance into engineering stream, technical stream again. So in addition to all these, if any person is seriously aspiring for the government jobs, preparing for competitive examinations, in that kind of session also this will be very much helpful. We retrieved the content from various platforms of previous year question papers and a detailed, more probably authentic information is provided. I will assure for that you will definitely achieve whatever dream you are aspiring for. That may be a career opportunity for higher education or else any kind of job opportunity. In that case also this kind of session will be very much helpful. Let's enter into our question number 1. Here the question is based on IUPAC nomenclature. This is the compound provided with 1, 2, 3, 4, 5, 6 carbon long chain. One of the carbon is having nitrile, another carbon is having oxo, that means ketonic one. If only ketone is there within the given compound, the compound will become alkanone. So this will become a intermediate. This will become the important one, important functional group, and the name is given in accordance with this one only. But in addition to this ketone, we have nitrile also. So that nitrile will get the higher priority over ketonic one. So that ketone will become a substituent and this will become a prefix over here. Right? So here for CN you have to indicate as a nitrile. So the common name, the common IUPAC name for the given compound is alkane nitrile. Alkane nitrile should be given, and being it is the kind of 1, 2, 3, 4, 5, 6 carbon chain, so that we have to mention hexane nitrile. And in that hexane nitrile, you can find the ketone on the 5th carbon atom, so that you have to mention it is a prefix at the 5th position called oxo. 5-oxohexane nitrile. 5-oxohexane nitrile is the IUPAC name of the given compound. This is the way we have to go with, and here parent chain will be the 6th carbon length. You have to go for hexane as the parent chain. Long chain will be taken into the consideration. This is the way we can assign the name as per the IUPAC nomenclature for the given organic compound. Move on to question number 2. The wavelength of the laser rays used in the eyesight treatment lays in the range of, right? Here laser rays are very essential. Without any kind of physical operation or surgery any kind, we can go with the optical surgery. So by using this laser rays, it is possible to correct the eyesight. That is laying in the range of 400 to 10,600, 40 to 400 nanometers, 500 to 20,000 nanometers, 10 to 100 nanometers. Among all, the correct answer will be 400 to 10,600 nanometers. Let's see detailed explanation. Here you can clearly observe how can we go for this kind of laser treatment, laser light directly used to correct the sight. Okay, the wavelength of laser currently used in the therapy for the surgery in the range of 400 to 10,600 nanometers. Surgical power densities and these wavelengths, because photonic ionization of atoms does not take place, laser rays are non-oncogenic. Non-oncogenic in the sense they are not causing any cancer diseases further, right? So this is harmless kind of radiation and most abundantly used in the treatments and surgeries in a medicinal field, right? For question number 2, option number A will be the correct answer. Laser rays laying in the range of 400 to 10,600 nanometers. Move on to question number 3. This is a question retrieved from the 2023 JEE Advanced question paper. Dissolving 1.24 grams of white phosphorus in boiling sodium hydroxide solution in an inert atmosphere gives a gas Q. Amount of copper sulfate in grams required to completely consume the gas Q is. If you observe carefully, white phosphorus is taken. Phosphorus is a kind of allotrope available in a different one. White will be there, red phosphorus will be there. In that way, the phosphorus is having P4. This allotrope is having catenation up to 4 phosphorus are combining. So P4 is the general white phosphorus composition and whose weight is given as 1.24. So now this P4 is added with sodium hydroxide. In the presence of inert atmosphere means any kind of ionizable gases may not be present. So that inert atmosphere generally can be taken with the noble gas or else a nitrogen also impart inert atmosphere. Okay, in the presence of nitrogen gas or else any noble gas can be employed in order to achieve this inert atmosphere, giving gas Q. So here phosphorus treating with sodium hydroxide Q will be the phosphine. Now it can be treated with further copper sulfate. Whenever copper sulfate is treated, how much gas of Q will be consumed? What will be the stoichiometric ratio that we have to find out? In order to get this, the data provided, hydrogen atomic mass is 1, oxygen will be 16, sodium resided with 23, phosphorus 31, sulfur 32, copper 63. This is the way atomic masses are provided and the amount of copper sulfate required to completely consume the gas Q will be 2.38 grams. Let's see how can we get this. Okay, in this initially the compound taken is phosphorus, that is white phosphorus of 1.24 grams. Let's calculate number of moles of phosphorus. Number of moles is equal to weight by gram molecular weight. Weight of the phosphorus is given as 1.24 grams. Phosphorus is taken as 31. Here data they provided phosphorus atomic weight is 31. But allotrope of phosphorus is having 4, P4 elemental form. So that 31 can be multiplied with 4. Hence, number of moles is equal to 0.01. 0.01 moles of phosphorus is there. That phosphorus is treated with sodium hydroxide and water. Formation of phosphine PH3 and sodium dihydrogen phosphate. Both the compounds are formed. Here, the compound Q, in this Q will be PH3 over here. So whatever unknown compound is given, that is phosphine PH3. So number of moles of P4 consumed is equal to number of moles of PH3 generated. So that we can say P4 number of moles just calculated as 0.01. Hence 0.01 moles of phosphine will be generated. Fine. So if you go for the next step reaction, this phosphine further treated with copper sulfate, so that copper phosphide will be formed and neither is sulfuric acid as the byproduct. Copper phosphide. Okay, here 2:3 ratio of phosphine with copper sulfate were taken. For the sake of 0.01 moles of phosphine, 0.01 moles of phosphine, copper sulfate consumed will be 3/2. Here we have to take the decimal value 3/2 into 0.01, right? So if you go for the expansion, 3 into 0.01 nothing but 0.03 by 2. So these many moles of copper sulfate consumed. So this is the number of moles of copper sulfate. Now go for the weight of copper sulfate. Weight of the copper sulfate is equal to number of moles into molecular weight. Copper sulfate number of moles are 0.03 by 2. Molecular weight of copper sulfate is given as 159. If you go for the calculation, the answer will be 2.38 grams. Weight of copper sulfate consumed will be 2.38, that is provided in option number B. Here, the number of steps we have to go for. First of all, what will be the stoichiometric equation among phosphorus and sodium hydroxide is known to you. That will be phosphorus reacted with sodium hydroxide giving PH3 along with sodium hydrogen phosphate. Now you have to find out number of moles of phosphorus over here. That equals to number of moles of phosphine generated in the inert atmosphere, that is called Q. Now, this PH3 is treated with copper sulfate. Whenever PH3 is treated with copper sulfate, you can get copper phosphide. Number of moles of copper sulfate consumed is equal to 0.01 into 3 by 2. Nothing but 0.03 by 2. So, if you want to get exact amount is equal to number of moles into molecular weight. Number of moles into molecular weight, if you go for the calculation, the final answer you will get for copper sulfate consumed. For question number 3, option number B will be the correct answer. Move on to question number 4. This is the one given from organic chemistry and physical chemistry is applied over here. Consider the following reaction. We have para-bromo-benzyl alcohol. This is called para-bromo-benzyl alcohol. It is treated with red phosphorus and bromine. Bromine addition is not the aromatic electrophilic addition because here this is not the Lewis acid. Red phosphorus is a reagent which gives the side chain bromination. It is the kind of nucleophilic substitution. OH minus now replaced with bromine. The product R will be bromo, right? Para-bromo, benzyl bromide will be the product R. On estimation of bromine, 1 gram of R used Carius method. Carius method, the amount of silver bromide formed. So, Carius method is the quantitative estimation of the amount of halides present in the given compound by using silver nitrate. Let me repeat. Carius method is the quantitative estimation of halides in the presence of silver nitrate. Okay. So, in that Carius method, the amount of silver bromide formed should be calculated. In order to get that one, first of all, we have to deduce the product. Initially, para-bromo-benzyl alcohol is treated with red phosphorus and bromine. Bromination is possible on the side chain. It is a kind of nucleophilic substitution. And the product R is called para-bromo-benzyl bromide. This para-bromo-benzyl bromide molecular weight is 250 gram per mole. Okay, so if you want to calculate for 1 gram of product R, number of moles is equal to 1 by 250 moles. Okay, for 1 gram, weight of number of moles is equal to weight by molecular weight. Weight is given as 1 gram. 1 by 250 moles. This is for R. R number of moles. Number of bromine atoms is equal to, how many are there? Within the compound you have 2 bromines, no? So that 2 by 250 moles. Moles of silver bromide is equal to 2 by 250 only because here if you see silver bromide, so here bromine number of bromines present are 2 only, that's why we have to mention 2 by 250 moles only. So here finally mass of silver bromide is given as mass nothing but amount of silver bromide is equal to number of moles into molecular weight of silver bromide. Number of moles of silver bromide is equal to 2 by 250. Now, because how many moles of bromide is there in the compound, those many moles of silver bromide is generated. Okay, law of conservation of mass. That's the reason why 2 by 250 is taken as number of moles of silver bromide and its molecular weight. Here within the question they provided atomic data, atomic mass is given. Silver is 108, bromine is 80. So that 108 plus 80 will become the molecular weight of silver bromide. 2 into 188 by 250. If you calculate entirely, the answer is 1.5 grams. Being it is the amount, you have to go for weight of weight of silver bromide formed is 1.504 grams. This is the way we have to deduce the answer from the given unknown question. For question number 4, the correct answer is 1.504 grams. First of all, we have to know what is the product of this reagent. After getting that, number of moles of R should be collected. After that, number of moles of bromine should be detected. So that number of moles of bromine is equal to number of moles of silver bromide formed because silver bromide is selective for the reaction with bromine only. So being 2 bromines, 2 moles of bromide will be there. So that number of moles is equal to 2 by 250 moles only. Then amount of silver bromide is equal to moles into molecular weight. Moles are 2 by 250, molecular weight is 188. So that the amount of silver bromide is 1.504. This is the way we can solve the question number 4. Let's move on to question number 5. This is given from the metallurgy and these are called minerals or ores for the given organic compounds. We have to identify which kind of metal it is. Sphalerite, siderite, malachite are the ores of metals. Sphalerite is the ore of X, siderite is the ore of Y, malachite is the ore of Z. Okay, so these are the elements and these are the minerals. The atomic number of them are respectively. If you know the composition of sphalerite, siderite and malachite, it's obvious to calculate what is the atomic numbers of these X, Y, Z elements. Okay. Sphalerite, siderite మరియు మాలకైట్లు వరుసగా XYZ అనే లోహాల యొక్క ధాతువులు. వాటి పరమాణు సంఖ్యలు వరుసగా XYZ యొక్క పరమాణు సంఖ్యలను మనం ఇక్కడ కనుక్కోవాలి. The correct answer is 30, 26 and 29. Let's see how can we get this. Sphalerite is called as sphalerite. It is the sulfide mineral and it is composed by zinc iron sulfide. Let me repeat. Sphalerite is the ore of zinc iron sulfide. So that here the metal is zinc. The important higher composition is zinc only. That's why we have to assign X as 30. Zinc is 30 atomic number. Move on to second, siderite. Siderite soils also present, no? Where you can find iron. Iron carbonate will be there. Siderite soils are composed with iron carbonate. Iron atomic number is given as 26. So that 30 is zinc, that is sphalerite, and siderite is iron carbonate, where 26 is the atomic number. Move on to Z, malachite. Malachite is made up of copper carbonate. Malachite is another copper carbonate hydroxide and chemical formula is Cu2CO3OH taken twice. So if you see this, copper is the metal resided in this malachite. So malachite or copper atomic number is taken as 29. Siderite is the zinc one, zinc iron sulfide will be there. Sphalerite. Siderite is iron carbonate atomic number 26. Malachite is the copper carbonate hydroxide will be there, where atomic number of copper is taken as 29. For question number 5, correct option will be option number A. Move on to question number 6. Here, consider the reaction P4 plus 3 NaOH plus 3 water gives rise to Q plus 3 NaH2PO4, right? So P4 is the phosphorus allotropic form treated with sodium hydroxide and water, obvious to get pH3 as the product. Identify the reaction in which Q is not the product. If Q is not formed, what is that we have to identify? Equations are not balanced. So whatever options are given in that, here Q compound first we have to know, and we have to know other equations also. In that, whatever this Q is there that is not generated, that we have to identify. Each area nu పరిగణించండి. P4 plus 3 NaOH plus 3 water gives rise to Q plus 3 NaH2PO4. Q ఉత్పన్నంగా ఏర్పడని చర్యను గుర్తించండి. సమీకరణాలు తుల్యం చేయబడలేదు అంటే వాటిని మనం కరెక్ట్ గా బ్యాలెన్స్ చేయలేదు, రైట్? సో హియర్ Ca3P2H2O gives rise to what are the products? H3PO3 upon heating, what are the products? PH4I plus KOH, what are the products? PCl3 plus H2O, what are the products? So if you compare all these, where the product here is Q, that is not forming. The correct option will be option number 4. Let's see how can we say. First reaction, problem reaction is P4 plus NaOH plus water. P4 plus NaOH plus water gives rise to Phosphine, pH 3 is called phosphine, and another byproduct is sodium hydrogen phosphate. Right, this pH 3 is called Q. This Q should not be there in that reaction, we have to identify. Fine. First option reaction is calcium phosphide plus water. Calcium phosphide plus water giving calcium hydroxide and pH3. Q is formed here. Second reaction, H3PO3 called orthophosphorus acid. Upon heating decomposed into H3PO4 and pH3. Here also you can get a pH3 called phosphine. So that here also Q is formed. And pH4i, phosphinium iodide, treated with potassium hydroxide. Product is pH3 and potassium iodide and water. Here also if you see pH3 is formed, means Q is there. But in case of this equation, PCl3 is treated with water, formation of HCl and H3PO3, where Q is not formed. Q is pH3. That Q is not found in this. So right answer will be PCl3 plus water. The products will be HCl and H3PO3. Phosphorus acid will be formed, but not Q. So among all these are able to give phosphine, but fourth equation is not giving. By this, we entirely completed the session. All 6 questions got detailedly explained over here. And hopefully the kind of session, whatever we discussed over here, is very much helpful for your further preparation. What you are aspiring for, definitely you can achieve the goal within the short time with the proper way of preparation. Hence, I'm requesting you to like the channel. Which part is helpful for you, that you have to comment regarding this video. Which kind of statement or which kind of content is helpful for your further preparation are interested about you, that you have to comment comment over here and share with the aspirants whoever preparing for the kind of examinations, any kind of entrance or competitive exams. Definitely it will be very much helpful. Subscribe the channels in order to receive more such kind of videos in the near future. And I'm requesting you to kindly go with the kind of sessions and watch the videos carefully. Thank you very much for your patient listening. Thank you one and all.